website we have a 2D example and a 3D example. So we have this data set. This is my original data set, and you can also change it out. Okay. See, you can already change it out, and you can get the values. Let's say we have all the values in this. Okay. So this is a 2D plane. Okay, and we are converting it to a single axis. So you see this data over here, what I have in the x-axis. If we see what this is, x and y, if we project the values, let me go up here. If we project the values down in the x, we will be having this x like this, and for y we will be having this. Now after you apply PCA, we will be getting the principal components by getting uh, the the point, the axis which will be storing out the most data. So see, for PC1, okay, this is the red line over here, the PC1. We have this straight line. Okay, and over here you can see all the 5 points. There is the maximum variance, so it is having a lot of information in itself. But for PC2 you can see PC2 is not having a lot of information. It has lost out most of the information in the stuff. So we are going to use PC1. We can use our model to train out on the data of PC1. Let's look into a 3D example. Okay, most of the time we will be working with many dimension, right? We will be working out as many dimension as possible. So in that scenario, what we are going to do is we cannot project each and everything, but let me show you example with the 3D example. We have this figure over here, and you can change out the figure accordingly, however you need. Okay, the spaces. Okay, this is what we get in the 3D projection. Okay, and if you convert it to PCA, okay, when we change it to PCA, we will be having the principal components. Okay, three axes: PC1, PC2, PC3, and you can see that in PC1 we have the maximum variance. Okay, maximum amount of variance, which tells that it is losing the least information. And similarly, once we move to PC2 and PC3, we will be losing more and more information. So that's about PCA. Before rolling everything out, the last thing that I would like to tell you is the applications of PCA. PCA is used in many places. Okay, probably, obviously, you are going to use when we are having dimensional data, but apart from that, we have other advantages too. These two advantages are something which are pretty common and used mostly in stuff. Okay, so principal component analysis can be used in image compression. Image can be resized as per the requirement, and patterns can be defined. So if you have a very big image data set, and training a model on that data set will take days and months probably sometimes. So what you are gonna do is, with a very trade-off on accuracy, you are going to apply PCA to have a quicker training model for that. Principal component analysis also help us in customer profiling based on demographics as well as intellect in the purchase. PCA is a technique that is widely used for researchers in food science field. It is used in banking field in many areas like applicants applying for loans, credit card, etc. Then it is used for data visualization. The main aspect is you cannot plot out an 10 dimensional or 1000 dimensional data, bigger dimensional data, but using PCA you can change it to a smaller dimension and then you can visualize the data. So these are few advantages of PCA. Now before we end this theoretical section, let's in our next video we are going to look into the steps of PCA, and then we are going to jump into the lab session. And if you are still not clear what PCA is, once we go through the lab section, I'm pretty sure that you will understand the importance and the need of PCA. So let's jump into the next video.